Thank you, Dr. Thangadurai, for inviting me to this platform. I must share with the participants with pride that Dr. Thangadurai is my senior in school, and he has been many years my senior, of course. And so it's a privilege to know him closely the last few years and interact with him. Uh, with that, let's begin. I'll share my screen. Is my screen viewable?
Your screen is visible, sir.
Okay. Yeah. Now, Dr. Thangadurai tried to explain about art integration. He also said that Rabindranath Tagore, said that he cannot define art. So that makes the job easy for many of us. If he could not define art, then it is pointless for us to try and define art. Now, the way I understand is, when a poet or a lover looks at the cloud, now he or she would look at the cloud as a messenger of love, as the cloud carrying your message to your loved one. That's the artist's way of looking at the universe. The scientist, when he or she looks at the cloud, is going to think whether it will bring rain or not, and when rain will come, and so on. Now, that's the scientific way of looking at the cloud. We have poets who have written on daffodils, who have written on cherry tree, and they have focused on the beauty and the joy of viewing and the joy of experiencing nature. On the other hand, the scientist in us would wonder why we don't have daffodils or cherry tree in India, why they are there in other countries, and here we have rose or lotus or mango. And they would have their theories. The scientists will build their theories on nature and on the universe. And so these are different ways of experiencing the universe. And I would not like to use the word integrate, because this knowledge is actually integrated in nature. Uh, it is in our course curriculum that we have divided them into subjects. And every subject teacher thus needs to understand that nature is integrated, and we must not look at our subject narrowly, or our students must not uh, look at these subjects narrowly. Maths is not distinct from nature, just as geography and science are not distinct from nature and not distinct from maths. Uh, so with that view, we need to begin now. Again, the scientists would say that, would have their theories on why daffodils or cherry tree are not so common in India, but lotus and marigold are. uh, so these are contextual truths. On the other hand, there are some perennial truths and or universal truths. Now, some of these universal truths are that if you love others, you feel happy. The child recognizes that or experiences that on his or her own. Now, and that is true of children across time, across continents. So that's a perennial truth. Children realize that they experience more happiness in collaboration and teamwork than they experience in competition. That's again a perennial truth. uh, we realize that when we serve others, there's real joy within, and we cannot deny that. Now, these are perennial truths. Now, the job of the teacher and the job of the parent, who is the natural teacher, is to open the doors of such perennial truths to the children, and to connect the child with such truths of nature. Now, to do that, of course, the the parent or the teacher has to connect with the child first. Now, and once you connect with the child will connect with you, and then the child will connect on their own, will pull on their inner resources and connect to nature and the perennial truths. Now, that's the job of the teacher. Now, maths is a context, English or language or Hindi is a context, geography is a context. We could be a subject teacher for one of these, but the essential responsibility of the teacher is to open the doors of the child to these eternal truths. With this background, I will focus on mathematics, but it does not detract in any way from the perennial truths that I talked about. And when we get into mathematics, it's about experiencing the joy of numbers. There is, you could call it art, you could call it magic in numbers. And the good maths teacher introduces the child, connects the child to that artwork that is inside maths. Now, I'll talk of some 10 principles of how one could do it. We'll begin with, the first principle: choose topics that we can connect to. We means the child can connect to, and of course the teacher can connect to. Now, one of my favorite questions is, what's the chance it will rain today? And I have seen that lots of children, adults, teachers, they will say, oh, it's half. Why half? Because it will either rain or it will not rain. So the chances are 1 in 2. In reality, we know it's not that the probability is half. It's different depending on whether you are in Meghalaya or Rajasthan. It's different on which month of the year it is. So that's a common misconception that comes in, and it's a good way to introduce one to the joys of probability and how it works. The first question that comes on probability is, when you toss a coin, what chance it falls heads on top? Now, and this almost everybody answers it correctly, that it's half. Probability is half that it falls heads and half that it falls tails. But then I talk of that incident in Sholay, when the coin stands on edge. Now, people of my age, Sholay was a favorite movie. Now, people who are in their 20s who are looking at the slides now, they probably may not have seen Sholay. But in Sholay, you have this scene where Amitabh and Dharmendra, they toss a coin to decide on something, and the coin stands on edge. Now, if heads it's half, tails it's half, my question is, what's the chance that stands on an edge? And now people get confused, and then they think, okay, there are 3 choices, so this is 1/3. But then is it 1/3 choice for heads and tails? Now that they need to figure out, and then there is confusion. We don't need to worry about confusion, because confusion is the first stage to learning. If you are not confused, you don't learn. In fact, knowing the right answer is a block to learning, because that's the last stage in learning. Now, if your purpose is learning, then confusion is a good thing. Confusion should lead to questions, and confusion should lead to exploration. The job of the teacher is to encourage that student to explore, to push the student towards questioning. Now, still they may find it difficult. Okay, we can play a game and illustrate. Keep tossing coins and find out how it happens. I have another favorite puzzle, which is more for college students or adults. One young man is in Bombay and is free on Sundays, and this young man has a choice. He can visit his mother or his girlfriend, but they stay in opposite directions. So he wants to be fair, and so he goes to the local train station and always takes the train which comes first. Now, it so happens that he lands up at his girlfriend's place 9 times out of 10. Now, how does it happen? Now, you'd say that, no, that train comes more frequently. No, I'm telling you that both trains have equal frequency, once in 10 minutes. Now, how does that happen? Your logic, your probability logic says, or your maths logic says that it should be 1/2. But the experiential logic here is, it is 9/10. How does it happen? So now, once again, I have created that confusion. You should be questioning, and this is a good premise to explore. We need to create interest in the subject. We need to provide interesting problems that are connected to real life, uh, like some of the ones we are discussing now. We use contemporary topics and attract attention. Now, let us assume today the contemporary topic, of course, is COVID. So build a story around COVID. Let us assume if you go out once and meet one random person for 1 hour, risk of contracting COVID is 5%. Now, it may or may not be 5%. Let's assume it is 5%. Now, then the question comes, if you go out and meet 10 random persons, each for 1 hour, how much is the risk? Now, you will intuit some answer, but the answer that you work out may not be what you thought. Now it's 40%. And then you get to another question, what if you met 20%? Now the answer is not 5% into 20, 100%, but the answer is 64%. Now, the idea again is, what's the actual percentage? It doesn't matter. But when we do this, the idea is to create interest in the topic. We could also see, these were some serious ways of calculation. We could also use distraction. In the 80s, a lot of planes were being hijacked. And I have picked this from a cartoon of R.K. Lakshman, actually from the 80s. And the hijacker usually had a bomb with which he will threaten the pilot. That used to be the story in the 80s of hijacking. Now, one frequent traveler was worried. He used to fly regularly by plane, so he was worried. He asked a math professor, what is the probability of one passenger in a flight carrying a bomb? The professor said 1 in 1,000. Now, he was even more worried. 1 in 1,000 is a big risk. He flies a lot. So he asked, what is the probability of 2 passengers carrying a bomb? And then the professor said 1 in a million. Now the traveler was assured this was a small risk. So to ensure 1 in a million, he started carrying a bomb every time he traveled. So, he reasoned, so a second guy in the flight having a bomb also is just 1 in a million chance. So he's safe. Now, this is of course a joke, but then very often jokes illustrate. Jokes illustrate what may be a serious talk cannot. The second principle, maths and numbers particularly is about patterns. And my job as a teacher is to let them discover patterns. Now, how can students discover patterns? Now, one of my favorite problems is, what is the sum of this? Now, don't use a formula. Now, adults and especially those who are good in maths immediately will do the calculation. Now, instead, and you must not use the formula with the child. Can you try rearranging and solve it? And this is one way of rearranging. And now once we rearrange it like this, the answer becomes obvious. And the joy is in discovering this magic. Now, you again don't tell them to do it exactly like this. Then there's no fun. As I told you, they get the answer, but what's the fun? There's no learning. Now they should discover it themselves. The correct answer, we need to realize as parents and teachers that the correct answer is not important anyway. How does it matter if the sum is 55 or 65? It just doesn't matter. The question that comes, if the correct answer doesn't matter, then what matters? The joy is in fun of exploring, and that joy matters. The eureka moment, I got it, aha moment, that is the reward. And can we keep creating such eureka moments, such intrinsic motivation for the child? And once they are interested in maths, once they are interested in the joy of numbers, now our job as a teacher or our job as a parent is done. They will seek knowledge or information on their own. Now, how to kill the fun? Now, if you really don't want them to enjoy maths, if you don't want them to explore, you just tell them the formula, that this is the formula. And that kills all the fun. It's like you go to a movie, a mystery movie, and in the first 5 minutes, somebody tells you who is the murderer. And that just kills, okay, you know the right answer. And you think, why wait 2 hours to find it out? But then it has killed the joy of the movie. And very often as parents and teachers, all the time we are killing that joy. We are preempting that joy. We are preventing the student from enjoying mathematics. And who would enjoy just looking at maths being just a compendium of 200 formulas? It will build up to 200 formulas by the time you're in 10th. Nobody enjoys mugging up 200 formulas. Now, you may think explaining so much looks difficult. Okay, begin small and simple. Progress incrementally. I'll explain in the next couple of slides what it means. Now, allowing discovery or waiting for Eureka. Now, Eureka won't happen when you plan it out. We have a lot of structured methods in teaching, but you cannot structure out the Eureka when it will happen. So it means it will not be a perfect ride. Every child will have a different ride. And there will be mistakes along the way, and then there will be frustration. Now, without mistakes, there's no learning. Without struggle, there's no learning. Without that frustration from not getting it right, there is no learning. Now, the good coach will keep the right mix of motivation and struggle. So how to keep it simple? 1 plus 2 plus 3 for 4. Can you do? Now, you don't need any structure. The child will probably get the answer straight away. So this was probably too simple. That's what I mean by you need to keep the right degree of struggle. Now, so you did not even need the rearrangement. And probably no fun in that. Okay, make it slightly more difficult. And then can you get this? And then probably the child will get this in rearranging in this manner. And thus you continue, and thus the child will discover the patterns. The child will discover that n plus 1 by 2 on her own. I'll come to a different game, which is again my favorite. Now, the game is about counting till 50. In fact, I learned it from a student or a set of students who asked me to play the game and defeated me at that game. And then I got interested. So you state a number. The game goes like this. You state a number from 1 to 10. And then I state a number from 1 to 10, you add them up, and then you state again, and then I state again, and we keep playing, we keep adding it up, and we keep playing till someone reaches 50. The winner is the one who reaches 50. So if I want to win, I must ensure that you, my adversary, you will not reach 50. So what is my strategy to ensure that you don't reach 50? So just to tell you how the game works. So first, let us say that you state a number 7, and then I state 5, it adds up to 12, and then you state 5 again, it adds up to 17, and we keep playing. And so now the child has to discover the strategy, and that's the fun in the game. Now, if you tell them the strategy to win, then there's no fun. The game really ends. So they must discover the pattern on their own on how to prevent the other side from reaching 50. They must discover the pattern on their own. And the game stays fun till one of them discovers the pattern. And after that, that person will keep winning all the time. It's the same as tic-tac-toe. It is similar, but easier. And they have to discover the pattern. And you know that after you have discovered the pattern in tic-tac-toe, you cannot be defeated. So this is principle 3. Begin small and simple, progress incrementally, and mistakes are progress. Every time a child makes a mistake, I am happy. I am happy because I know the child is learning. The child is questioning. The child is trying on her own. If they get the right answer straight away in this world of Google, I am pretty skeptic. Did they really learn? Did they really get it? Perfect answers don't always imply learning. Mistakes imply struggle. Struggle suggests the motivation to learn. If you don't have motivation, you won't struggle. Why should you struggle? Now, keeping it simple, another example, the 8 queens problem. In a chessboard, you arrange 8 queens such that no queen can cut another queen. Now, that is a slightly difficult problem. And the child, say class 4 student, class 5 student may find it difficult. But then you make it a 4 queens problem on a 4x4 board, and that becomes an easier problem. And once they solve that, then can you go to a 5x5 board and then progressively move towards a 8 queens problem. This is a real example by a child. Again, how of simplifying. This is a 4x4 Sudoku. Okay, and now that's fairly simple for a whole lot of children. The original Sudoku might be tough, but a good way to get them interested is give them a simpler Sudoku. But you see, the child here has made a mistake. And this is such a mistake, you don't even need to, go and correct that. You just need to point out the mistake, and the child will discover the right answer on her own. And that's the way the interest in Sudoku gets built. And then you give a slightly more difficult Sudoku. once this is done, test for deeper understanding. Now, what does so very often the child gives the right answer and then we are happy. Okay, they could do it. No, no, but then I want to verify, did they really understand? For example, give a slight twist of 1 plus 2 till 6, I give 2 plus 3 till 7. Now have they understood? Or slightly more difficult, can they do this? Now, once they can do this, then I realize, yeah, they have got the hang. Now, I have seen in the NCERT textbooks, maths textbooks, you have many interesting stories are there, stories and puzzles in the textbooks. We need to discuss the puzzles, but it's not enough to just solve the puzzles. Create similar puzzles and check for understanding. Create more and more puzzles of a similar nature. Ask them to create similar puzzles. Now, can you create a puzzle like this? And once they are able to do that, then you know that they have got the magic. Now another way, can we shift the frame or change the base of the problem? Now here the problem is, see, these are the marks, ICSE marks in 6 subjects that a student has got. And what is the sum? Now adding such big numbers may look difficult and time consuming. Now is there a faster way? Now can we think of base 90? And when we think base 90, now 88 looks like 90 minus 2 and 93 is 90 plus 3. So we have converted the numbers into a convenient form with respect to 90. And then we see that, minus 2 and plus 2, they cancel out each other. Plus 3 and minus 3, we don't need to do anything. So what remains is minus 4 and plus 1. They total to minus 3. That is easy. And so we add up all the 90s and do minus 3, and we have got the answer. So this is how, we can solve a whole lot of problems. The next principle, and this I think is the primary job of a maths teacher, is can we create an intuitive feel for numbers? What is an intuitive feel? 88, when I think 88, it is 90 minus 2. I could also think it is 8 into 11 and so on. 105 to me means 5 more than 100. 60 multiplied by 90 means it must be bigger than 50 multiplied by 90. This is what I mean by intuitive feel. Now, this intuitive feel becomes very useful in real life also. You go to a restaurant where the average dish costs 300 rupees. And we will order 4 dishes. There are 4 of us, and we will order probably 4 dishes and rotis. So the bill probably will be around 1600 rupees. When we think like that, without actually having added up the numbers, now then we are having an intuitive feel. How does it help? If the bill comes to 1800 rupees, we don't need to add up. You just pay and go. But if the bill comes to 3000 rupees, now then I'm going to add up. And very often that helps. Similarly, multiplication tables, let's say tables of 9, there's a pattern. Now, can the student discover the pattern on her own? Tables of 5, they anyway notice the patterns. I've seen that most children, they know the patterns in the tables of 5. The next principle is, can we teach from first principles? Multiplication tables are good and lots of children are subjected to memorizing them. I have no problem with memorizing. Memory is a very important component, of learning. However, they must also know that multiplication really is repeated addition. Okay, and once you know that, then you have a choice to memorize the tables, and that's good. And I can tell you, you can survive without memorizing multiplication tables. I did not memorize. I survived. My sons did not memorize. They have survived. So it's not that it is essential part of education that you have to memorize multiplication tables. I can do the subtraction, and any child actually can do. Any child beyond class 2, can do the subtraction of 52 minus 26. But I have seen even engineering students, computer science students, get stumped if I ask them, but how are you doing? You tell me. You are doing a borrow from 5, but you are borrowing 1 from 5, and then you are adding 10 to 2. Why are you adding 10 to 2 when you are just borrowing 1 and you are adding 2? Now that's not fair. How do you do it? And a whole lot of children, they are not able to do it. Now, does it matter that you don't know? Yes, it does matter, because if you have understood positional logic, if you have understood decimal arithmetic extremely well, then binary arithmetic is a breeze. But if you just memorize these things, that this is a method I need to memorize, and you did not understand decimal arithmetic, then binary arithmetic becomes a core when you study computer science later. Similarly, did they really learn fractions, or did they just identify higher denominator is lower value? Children are good at patterns. They know that 1 by 7 is smaller than 1 by 5, but they did not really understand fractions. And you think that they are solving it correctly, but when it comes to ratios a few classes later, then they find it extremely difficult. And that is because, not because ratios are difficult, this is because they didn't understand fractions. We need to create interest with some magic, and the maths teacher, probably more than many other teachers, has the opportunity to show a lot of magic. Now, for example, multiples of 3, if you add up the digits, they also are multiples of 3. So for example, 213 adds up to 2 plus 1 plus 3, 6. And so 213 must be a multiple of 3. Similar rules for multiple of 9. They add up to, they always add up to 9. So when we show such tricks to children, and building on this, there are a lot of other tricks on how to verify multiplication quickly. Now children get interested. We adults, we love magic. Children love magic equally. And when they can perform magic, they would love numbers. Some other magic which are more difficult to perform, 55 into 55, the rule here is if the second, if the unit digits, they add up to 10, here 5 and 5 add up to 10, and the first digit, they are the same, then the rule is, that same thing, 5 into 6, you do 30, and 5 into 5, 25. So the answer is 3025. Another example, similar, 63 into 67, again 3 and 7 add up to 10. So this rule will apply, and 6 and 6 are the same, so it becomes 4221. So that's another kind of magic. 91 square is 8100 plus 90 plus 91. Or 81 square is 6400 plus 80 plus 81. All of you who are maths teachers, you know why these things work. Now, initially, the child does not need to know why these things work. You go into those algebraic equations, those become more difficult. They will discover it as they go along. But first, let them enjoy the magic. Now, some of them may be brilliant students, very curious students, they may not leave you. And okay, it is worth going all the way to them and try to explain the equations, try to explain why this is so. But most other children will just enjoy the magic, and then they will try to show this magic to other people. In the bargain, they also become faster at mathematical calculations. The idea again here is, I want to introduce you, the student, to the joy of numbers. So mathematics is an exciting subject for you. Now, I'm not going to teach you all the formula, that you will discover that on your own. The logic, as I said, the logic will follow, and the more curious will learn it faster. The less curious will also learn it eventually. But then let them discover at their own pace. Another interesting problem is the multiplier effect. There are a lot of stories on this also, that come in stories, riddles, textbooks. Essentially the power of exponentiation, or the power of compound interest. Now, when you are 10 years old, if you put 100 rupees in a long-term fixed deposit, 15% interest, it becomes 201 rupees in 5 years. That's not so interesting. But it becomes 1 lakh or more in 50 years. Now, that's interesting. So, however, if you saved late, and let's say you saved this only when you are 50 years old, then you will need to deposit 23,000 rupees, not 100 rupees, to get 1 lakh when you are 60. Now, there are other lessons in this. If you start good habits at 10, now it becomes very easy to reap the rewards for years, rather than starting good habits at 50. Those good habits may be with respect to academics, it may be with respect to health. So that's how you could connect a compound interest, a maths problem, with a real life problem. This one I found pretty interesting. NCERT textbook in class 3, it says estimate the number of dots in this box. And I find the estimation a very, very interesting area, because it teaches about life, it teaches about assumptions we make about nature, and based on how good our estimate is with the eventually correct answer, now we will know how good our assumptions are. And as we keep converging, towards the right answers, we keep questioning our assumptions, and our understanding of nature, our understanding of realities become a lot better. So it's very, very important, I feel, to teach estimation to children. Maths teachers more so, because a lot of estimation is about numbers. So here, of course, they also make it easy. It's a class 3 estimation. They make it easy to estimate by creating a lot of structures inside, as you see. But the main thing again is, can you estimate? The exact answer is not important, but the reflection after you get that answer, that is important. Why I didn't get it right? Next time, can I get it better? So examples of estimation you could try out, estimation of size of a vessel or a bucket, estimate weight of cereals or weight of spice. They come in different orders of magnitude. Uh, Estimate the water needed to drink and to cook, or water needed for a shower or for bath with a bucket, or to clean the car with a bucket or a hose pipe. Now you see, when many of these you understand, how much water you are using or how much water you are wasting, you also become socially responsible in different ways. So this is all connected with nature, all connected with realities. You can estimate the quantity of ingredients in a recipe. Now, the recipe may say that prepare this for 10 people, but then at home you want to prepare for only 4 people. Now, how do you know? And once you are able to do it, they may enjoy cooking. And when you estimate the quantity of ingredients in this manner, after reading in the recipe book, you have learnt about ratios. You have learnt about ratios without understanding that you have learnt about ratios. Another favorite one, I love Atlas and I love geography. Find the largest countries in Asia. Now, if you memorize from somewhere, that's not interesting. Now, once you look at the map and you find the largest countries, you learn a lot about many different countries. That's one big advantage. So you don't just learn what are the largest countries, you learn other things also. You also, again, learn to estimate based on size. You will not be exactly right, but how does it matter? The tendency is to Google right away and get the answer. So what? That's not interesting. You can anyway Google whenever you want to. But looking at a map, or looking at the size of anything, can you estimate whether it is bigger and smaller? Can you estimate, for example, here Kazakhstan is bigger than Saudi Arabia or not? Now, that's an interesting exercise. Similarly, can you estimate the 5 longest rivers in India? Once again, in doing this job, you will learn about the rivers of India, but you will also learn how to estimate length of, unstructured figures, unstructured lines. Can you estimate the time needed to get to front of a queue? I have found this very useful many times. It's particularly useful when you are trying to check in and that mandatory 45 minutes or 60 minutes you have come in late and you don't know whether you want to panic. So this estimation is extremely useful for me. The size of your room. Can you estimate the size of your room, size of a football field? See, these are much more interesting ways to learn maths than multiplying by some things. What's the biggest size stick that can fit into the classroom? Time you will take to complete a task. This is very important for planning and organizing. Lots of adults, lots of successful professionals cannot do it right. And it is easy to learn from the time you are a child. And can you estimate? Your estimate will go wrong. You figure out what the assumptions were and then make the assumptions better and better and better every time. There has to be reflection, of course. After in all this that I'm telling, yes, you will make mistakes, but then there has to be reflection on why I made the mistake. Estimate who will win the match. Now, this one is Shakuntala Devi. I was fortunate that when I was in class 6, Shakuntala Devi came to our town and she also gave a performance in our school. And I got extremely interested. Anybody, of course, who has seen Shakuntala Devi has been intrigued and inspired. And I was no exception. And one thing that I thought, let me try. Now, you give any date and she could tell the day immediately. Now, I thought this is a very structured, bounded problem and I should be able to do it. And then, of course, I explored and then I could do it, in a couple of months after watching Shakuntala Devi, not as fast, but I could tell in a few seconds. Now, this is the value of exposure. If I were not exposed to Shakuntala Devi in class 6, I probably would not have thought about that. As teachers, parents, educators, schools, our job is to create exposure for our children, that they get the motive to explore. Adding up 1 to 100 again, in class 5, my maths teacher told a story about how there was a lazy teacher. He wanted to sleep. And so he told the students, you add up 1 to 100. That's where I began my presentation, actually. And then he went and he would go to sleep. But then there was one very smart student who later became one of the famous Greek philosophers. Now he found a quick way to do it. Now, and when he told this story, now I also thought that let me go and figure out, and in class 5 I had figured out how to do it without learning about arithmetic progression or the formulas for that. So it's the exposure. That story motivated me to do this. Now, can you tell stories? Now again, if the formula were given, most children would not be interested. There'll be some very studious people who would be interested, but when you tell stories like this, yes, children do get interested. Magic squares, again, we did it in a similar way. Now our calendar story with Shakuntala Devi did not end there. I found after that there's an easy way to find square roots. And then I would go around in my class and tell that, see, I can tell you square roots quickly. And then I had one friend who then saw this. He discovered it on his own, how I was doing. And then he started doing cube roots. So he had to go one up, and he did. And so this is the power of exploration, the power of, osmosis of interests. Similarly, puzzles and paradoxes, this can keep the joy of learning alive, the curiosity for numbers alive. Now, this one again is from a class 3 textbook. This is the last thing I'm going to talk about. You see, there was a king who loved horses, and the king could count only till 9. Now, as you see here, in each box, there are 3 horses and there are 24 horses. But the king could count only till 9. So he arranged them in this order, 3 in this order. And so every row and column he could count till 9. So he knew that his horses are intact. So this is how the horses were organized. Now, what happened was there was some other traveler with a few horses who came with 4 horses, and he wanted to park the horses in the king's stable for the night. Now, the stable keeper was afraid that the king will find out. Okay, then he will be in trouble. But this fellow told, no, don't worry. The king cannot find out. And so, because the king can count till 9. And so he organized the horses in this manner. So you see, this adds up to 28. So 4 more horses came in, but the king calculated at night that or in the morning, that there are 9. And so there's no problem. So now the traveler got a idea, got a clever idea that the king can count till 9 and he can be fooled this way. And so now he took away 4 more horses. He took his 4 horses plus 4 more. So you see, this still at all rows and columns, they still add up to 9. But you see, now the count has become 20, total count. And the king could not find out. Now, so this is a good joke. Students enjoy it. But this is also a good puzzle. But the question here is, I'm not sure they have got the puzzle, but did they get the issue? Did they get the real issue here? And how did the king get fooled, or how did the traveler manage to fool the king? And so for that, I created another puzzle, which is similar, to test out whether the student got it right or not. Now, so those are things, we should build from one puzzle into another. And the puzzles are important because they generate interest and create curiosity. But one also needs to create follow-on puzzles and games to verify. So, summarizing, there were 10 principles that I talked about. So choose topics we can connect to. And I talked of chance and risk taking. There can be other topics. I chose this because I love this. Let them discover patterns, not that we will show them the patterns. Don't give them the formula. Use games and puzzles. Third principle, begin small and simple. Progress slowly. Mistakes imply progress. Test for deeper understanding. See, I'm not joking with you. I actually get very happy when children make mistakes, because that I know then that they are trying on their own. Shift the frame. Develop an intuitive feel for numbers. Encourage first principles. Means do it yourself. Indulge in some magic. Inspire some awe. Estimation needs to be learned. I believe that is a necessary skill for life. And who else but a maths teacher can teach this and create exposure to inspire. Now, with that, my talk is over, and we can move to the next phase. And I'm sure there are question and answer, and I'll be very happy to take those questions.
Thank you so much, sir. That was indeed very interesting and magical, as you say it. So, without further ado, I would now like to just make a few announcements before we could move on to.
Before you make the announcement, Kushbu,
Yes.
uh, I really should thank Kalyan. Very interesting way he put it across, and I think all the teachers of maths should take a lesson from his explorative and experiential learning. Um, and how beautifully he integrated. The word integrate means to make a whole or complete, um, by bringing in other experiences. And his horse's story, his learning by mistake, and the fact about exploration. And the very best thing I liked about his talk was the innate knowledge of a child. A child is always, because being a educationist, that educational psychology is that a child is always comes with an innate knowledge. Very often, I sometimes talk to small kids when they come for admission. I said, you count. I give them something to count. They say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, I stopped them at 5 or something. I said, count again. When I say count again, they don't count from where they stopped. They go back and count. So their innate knowledge is that there is a beginning and an end. Anyway, that's the beauty of innate knowledge. And what Kalyan has brought about with this exemplars, I would say, is how you can bring about the conceptual change. A child always bears a concept, which either by innate or by pre learning come to the class with that kind of a concept. For example, any number we multiply, it's always becomes larger. Any multiplication is a larger number. But if you multiply 10 into half, it becomes less. Now that conceptual change has to be brought about in a child. Why does it become half? Similarly, 1, 2, 3, 4 is greater than 1, 2, 3. But if you have 0.1234, that conceptual change has to be brought. Why such a big number and still it is less? The concept is the decimal place value. So these are the things which I have observed, because there are many learnings I do by way of observing classes. That is how we become experienced, by observing classes and by listening to some of the beautiful exemplary examples that teachers do. So here is what Mrs. Uma would be coming across to share with us. And the best part of it is, even talking about physics also, people assume that everything, an object always moves in a straight line. Yes, it is true while traveling in a straight line, but a car, when we are traveling, I don't think I think the left and the right doors are not moving in the same direction, especially when it is moving around a circular track. You see, these are experiences by which we go by car, and we can still teach our children who are traveling with us on a circular track. So this is a conceptual change, and I think Kalyan brought about very beautifully, and even he summarized it towards the end, the 10 points. That's like a 10 commandments that he brought about. And I should thank about his how immersed he is and in finding out solution, just like Rabindranath Tagore. wanted to find out how well his son could study and brought nurture and nature together. So thank you, Kalyan.